Welcome to the fourth part of Chapter 18. In this part, we are going to be looking at how do things become charged. Okay, so in the great realm of charged things, what we have are protons and electrons. And protons and electrons can lead to things being positively and negatively charged. I like to view everything as either an overabundance of electrons, meaning that the object is negatively charged, or too few electrons, meaning that the object is positively charged. And the reason for this is because the electrons are the things that can change their position. As we saw in part 1, when we rubbed the balloon on the sweater, the electrons shifted from the sweater to the balloon while the protons in the sweater stayed put. Or similarly, when we looked at the balloon coming near the wall, the electrons were the electrons in the wall shifted while the protons in the wall pretty much stayed where they were because they're in the nucleus. So there are two means of something becoming charged. First, we can charge by contact, and that is literally done by taking something that is charged, say a positively charged rod, and touching it to something else that will cause some of the electrons from this something else, if it's a conductor, to move onto the rod because they're attracted to those positive charges. And when we separate these two things, the rod is potentially still positively charged, and the other object there is now positively charged as well because it lost some of its electrons to the rod. Okay. That's charging by contact. You literally bring two things in contact with each other. The other means of charging is charging by induction, and this one is more subtle. Before we go into this really quick, when charging by contact, you end up with the same charge. So I started with a positively charged rod, and in the end, both of my objects were positively charged. Okay, now back to charging by induction. Again, this is much more subtle, but we're going to work with it. So I have my positively charged object, and I have my other object, a conductor. And what I'm going to do is, instead of bringing my positively charged object toward or in to touch it, instead I'm going to open up another path. And that other path needs to go to an electrical ground. This could be your finger, for example, just some large source of positive and negative charges. The negative charges in the large source, the ground, are free to move. And they see this positive object and they say, ooh, we're attracted. And so they all come and they pile up on this conductor. I'm now going to break this path, remove it. Okay. So when I break that path, those electrons no longer have a means of escaping. They're stuck on that object. And now when I separate my two objects and move them apart, I end up with my positively charged rod, and my other object, my second object there, is negatively charged. I could do this same process starting with a negatively charged rod, my neutral object. I open up a path to ground. And now the negatives that are on this object say, ah, scary, and they run away from the negative rod. Opposites attract, likes repel, leaving me unbalanced positive charges here, so that when I break this connection, right, I now have an excess number of electrons in the ground, but my second object is positively charged. So you can see in both cases, I end up with an oppositely charged object. Okay. So let's think about conducting spheres and what happens when we bring them into contact with each other. So I have a 3 coulomb conducting sphere. It comes into contact with a neutral conducting sphere. So here it is, initially neutral. Okay, so they're brought into contact. When they're separated, what happens with the charge? Well, hopefully it's not too big of a surprise that I end up with 2 1.5 coulomb charged spheres. I'm now going to take my 2 1.5 coulomb spheres and bring them into contact with a third sphere with a negative 5 coulomb charge. And I want to know what the final charge on this will be. Okay. On average, or in total, if you will, I have 3 coulombs of positive charge and negative 5 coulombs of negative charge, which gives me a net charge of negative 2. So when I separate these, I will end up with negative 2/3 of a coulomb on each of my 3 spheres. This concludes section 4 of chapter 18.